Hello, in today's video we are going to learn how to code in Unity with C#. So first, what we need to do is to create C# script, and let's call it tutorial 1. Okay, for our script to be initialized, we need a game object that will be loaded when we press play on our scene. So what we need to do is just to create empty game object. Let's rename it maybe to tutorial. And also it's a good habit in inspector to reset all the transforms all the time when we create our game object. Okay, so let's attach our tutorial 1 script to our tutorial game object. So as you can see here, our script is attached to our game object, and every time when we press play, our script will be initialized together with our game object present in our scene. Okay, to start learning how to code in C#, just double click on your script, it's my script here, tutorial 1, and today we'll talk about variables and access modifiers to our variables. So what is the most important for our variables, for our code, is our various variables. You can call it as you want. So first I will show you how to create your first value inside your game. So here we have accessor. We have three types of accessors. Public, three types you will be using during your coding. So I'm usually using public, private, and static modifiers. So this is let's declare our first value, and we'll talk how it works. So let's write public int. It's shortened from integer. Let's write x1. Okay. So we've just declared our first value, and to show you how it works, we press Ctrl Save and go to Unity. And when you go to your game object, here you can see here that first your first value, the x0, was initialized. x1 is equal to 0. Okay. So what has just happened here is that here, as I said, you have public modifiers. So we just created int value, and for int value we can provide our integer values like 0 or 1, 2 or 3, or maybe -1, -2. First we'll talk about the values and then variables, and then we'll talk about access modifiers. Okay, so first let's follow with the values we will be using the most during our coding. So the second one you will be most using is float. Let's write maybe the 1. Okay, and the second one, let's write public, double. Yeah, let's write something like that. Okay, and what's the difference between float and double is both of them can take values like 0.1, for example 3, minus 0.1, full values like 1. Yeah. Okay, so you see the difference between integer and float now. So for the double, the values it can take, it's almost the same, just the difference you are interested in for your coding during your game design is that this one is efficient, is memory efficient. Okay, so this one is memory. So the float value takes less space inside computer memory. So if you run short on memory during game design or coding, you should use float values. But when you want values that are more precise and faster, calculated faster, So you should use double value. Okay, so that's the difference. This one is the processors read double faster than float value. Okay, the other types you will be using are values like public, char, that's right, C1, okay, and public string, that's right, that's this one, okay. So char is like, you just use letter like C, B, yeah, or maybe that's right, A, B, C, D, full alphabet, okay. But for the string values, it's like you write full name. So you can write name of item here, name of person, so like John, and that full value will be stored inside that value. If you use char character, you can just store one letter inside this value. Okay. Another one that is very useful is bool value. And that's right. Oh, sorry, not void. Bool b1. Okay. So if you write bool value, you can only say it's true or false. Okay. Let's press Ctrl S and let's go to our Unity, and I will show you what has changed. So here I can provide values like 1. For float, I can provide value like 0.1, the same for day1, 0.3. For char, I can like say, let's say a letter, and for string, let's say Adam. We can provide full name, and for the b1, it's our bool value, so we can just match true or false. And those are the values we can declare inside our inspector. As you can see here, if they are public, we can access those values from the Unity menu, or you can call it how you want, from the Unity inspector. Yeah. Okay. So that is what public modifier allows, and also the public modifier will allow us to access these values from another script. So if you would like our value to be more protected or encapsulated, how we call it, so it would be, you would like to have to write private x int x2. So now what will happen? It still get the same values. That's our integer x1. It can get the same type of values. But what happens here is that when we go to our script, as you can see here, to our Unity window, as you can see here, it doesn't show. We can find our value if we go to debug mode. There is our x2 value, but it's protected and we can't change it in any way, on any way. So that means this one is protected value. Okay, and you can only change this value from inside your class or script tutorial 1. Okay, you can't change this from outside. Of course, you can create public method inside your script that will change that x2 value, but I will teach you how to do it in next episodes. Okay, so for now, just please remember that this way we'll encapsulate our x2 value, that it will not be changed by accident. But why we write public is that For example, if we want to test our game on some speed or HP values, or we want to test the force of jump of our player, it's easier for us to write public values because we can change it all the time in the inspector. So it's very useful for testing and balancing our game. Okay, so we have public modifier and private modifier. We have also, we can write static int x3. What static means? That this value will not be destroyed when we reload our scene. So the scene is this one, what you can see here, and this is what you will build. If we create value of public or just private type, when we create our static value, when we create just values, declare values like that, they will be destroyed when we switch scenes. So for example, if you build levels in your game, that each level is different scene, the value x3 will be destroyed when you load another scene. So for example, if you would like to have money value inside your game, this money value would be 0 when we load next scene. So if you will make it static, the value will not be destroyed. The value will be destroyed only when you will close your game. So if I will write public static integer x3, I will show you how it works. I will create another script just for let's call it blah 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 blah. Okay, let's call it blah blah blah. And when I will let me open it, and I will be able to access this value from another script. So if I would like to change it inside another script, this is the start method. Don't focus on that. I will explain it in the next episode. Okay, so for now, just notice that I should be able to call my x3 value. Okay, 1 second. x3 value. So I'm able to call it without any declaration. So I can change it from another script. I can read it and find what is the name of the script. Of course, I can also access public values from this script, from another script. But to do that, I need one more operation. I will explain it later. So what I want to tell you how the static value works is that it's visible through whole life cycle of your game. That's how the static value works. So public, private, and static are very useful accessor type of your values. So that's 3 types you will be using by your whole life as game designers. And also that's the other values I'm using. And there are also two very important values, which is vectors. Depends on what type of game you are creating. It's our vector vector v3 v2 vector 2 and public vector. I will show you how they look like. This is the this one you will be using when you are working on 2D game, and this one is the vector type you will be working when you are creating 3D game. So how they work is that you have here defined where's my vectors? Okay, I have Okay, one mistake on our script. Okay, this one I haven't saved. Okay, and it's causing error on another one, so that's why it doesn't want to compile. Okay, here. So when you look on your scene, maybe game object, 3D object, cube. Okay, let's focus on our cube. Let's turn off 2D and let's focus on our cube. So I will explain you how the vectors work a little bit. It's not tutorial on the vectors, so it will be a quick explanation. So when you are on the 2D view, so your game object will be described by two vectors. So those two vectors is the positions of your cube. So if you will look here, the position X and position Y. So those values inside your vector is exactly those positions on your view, so or on your area of your game or your scene. Okay, so they start. So your point 0, 0 is here, and here is X value. Here is Y values, and here you have X values. Okay. Okay, I think it's clear. So that's how you declare your vectors. And the same situation is for vector 3, but when you turn off, you will see there is another one. It's depth of your vector depth. So you can think of it as a depth, or yeah, I think it would be best to think as depth of your scene of the vector. So it's the third value, the value z. Okay, so here you have all the values you are going to be using through your whole game design. This is the values I'm using. Most of them, the rest of them is rarely used, so I would recommend at least on the start to focus on all that what you have here to understand all of that, how it works. And just as a bonus, I will show you. Let's write start, and here we need to also talk about casting, because when you have float value like f1, of course on the start method, for now just please understand that this one will be called when the script is instantiated. So this one will be called together with your script when your game object will be shown on the scene. So for us, how we created it, it will be when we just press play. Okay, so that's, and all instructions inside that function will be called when you press start on our game, when our object will be instantiated inside our scene. So for us, how we build it, it will be on the start of our scene. Okay, so here if I press F1 and I will try to write 0.5, we'll have an error. And why? It's because values by default inside values after commas and are by default read by the compiler as double values. Okay, so we need something called casting values. So for now, if we would like to, we can cast this value as float just by writing f at the end of our value. So now our compiler will compile 0.5 as float value. Okay, but if you would like cast it from the name, just please remember it for now. So if you would like to cast it as for example d1, so which is our double value, we again have an error because we can't. Compile doesn't know how to read the double one value as f1. So we can use casting to write float. Okay, like that. And now everything will be fine. Of course, it will be read by f1, but we will lose our precise. Okay, our precision, and also it will be calculated slower, but it will be more efficient for the memory. For your knowledge, you will probably, as a single developer, this doesn't matter for you which are the faster and which one saves you memory. Computer today are so fast that you will probably not notice during your single person game development, or even when you're working on 4 or 5 man teams. Okay, just have that in mind. Okay, so as a bonus, maybe we'll do some calculation. Oh, maybe I will show you. Okay, let's do some calculations first. Let's write here. Maybe let's create some result for our values. Public int result. So let's do some calculations. I will show you how it works. So let's write result is equal to our, maybe let's do float result. It will be float type because we will add maybe f1 value and integer. Okay, let's delete those one. So let's add our x1 value to our and our f1 value. So x1 is integer, and as I said, the float values can take this value, so there is no need anyway for the casting integers as floats. So we just add integer to float, and we'll have our result, which is type of the float, the type of float. Okay, sorry, misclick here. Oh, I closed this one. Okay, but anyway, so first let's write our result. Let's declare our values. The x1 will be 2. Our float, let's say it's 0.7. Okay, and let's go again to our script. And for now, our result, is here. Okay, so our result is not yet calculated because, as I said, the instruction inside the start method will be called when our game object will be instantiated inside our scene. So this one, if you press play, see here, our function was, our instruction was done, and we have the result of our calculation, which is 2.7. Okay, I hope all of that is clear. If you have any question, please comment, and if I could say something more clear, please also write it inside the comment. Okay, I will show you also how to the easier way for this will be using for debugging. Debug log. This will be used for, you will use this function probably when you will do some debugging. You could also show your result inside your console. So to do that, because here in the console you will receive all your errors, so also it will be useful for you to be able to throw some logs or values to your console and to see what's happening in your game. Sometimes it's easier to understand code when you do debug logs. So if I press play now, as you can see here, my value 2.7, which is actually my result, is thrown inside the console. Okay, so that's what debug logs does for me. Okay, so that's all in today's tutorial. If something is unclear, please comment, and I will do additional explanation in comments or in next episode. Please also ask questions if you have any, so I will answer them. Okay, if you like the video, don't forget to subscribe and to press the thumb up. And thank you for watching.